Hey everyone, welcome back. In previous videos, we've only briefly mentioned branches. Branches are an important part of the Git workflow, so we'll branch out and explore them more thoroughly in this video. We'll also explore merging. Merging is the term that Git uses for combining branch data and history together. So let's get started. You might remember that we talked about branches in the context of the head pointer. So what is a branch? What is it used for? In Git, a branch at the most basic level is just a pointer to a particular commit. But more importantly, it represents an independent line of development in a project, of which the commit it points to is the latest link in a chain of developing history. The default branch that Git creates for you when a new repository initialized is called master. All of our examples and development have taken place on this branch so far. The master branch is commonly used to represent the known good state of a project. When you want to develop a feature or try something new in your project, you can create a separate branch to do your work without worrying about messing up this current working state. Branches make it really easy to experiment with new ideas or strategies in projects. When you want to add a feature or fix something, you can create a new branch and do your development there. You can merge back into the master branch when you've got something you like, or discard your changes without negative impact if they don't work out. In Git, branches are used all the time as a part of the normal development workflow. As an example, think back to the problematic commit we fixed earlier. We added a call to the disk full function, but forgot to actually define the function. So we had to roll it back because our users were seeing errors. Knowing what we know now, we could have done that work on a separate branch, maybe called something like add disk full. In that case, we could have iterated on our code there until it was working correctly without it affecting the master branch. Only after the code is ready to be deployed, we would merge those changes back into the master branch. We'll look into how to create new branches and merge their content into the master branch. We'll also go over what to do if you run into any scary merge conflicts. Heads up, this is about to get pretty complicated. As branches are essential to how work is done in Git, there's tons of different ways to work with them. We can use the git branch command to list, create, delete, and manipulate branches. Running git branch by itself will show you a list of all the branches in your repository. Let's try it out in our checks repo. Our list is looking pretty empty right now, but don't worry. Creating a branch is a snap. We do it by calling git branch with the name of the new branch. Let's create a new feature branch and then list the branches again with git branch. Our new branch was created based on the value of head. Remember that this might not necessarily be the master branch. The list we get shows that we're still on the master branch. We can tell because the current branch is indicated in the command's output with an asterisk in a different color. We'll look into other things that git branch lets us do with branches later on, but right now we want to switch to a new branch. To do that, we'll need to use the git checkout command. We saw earlier how we can use git checkout to restore a modified file back to the latest commit. Checking out branches is similar in that the working tree is updated to match the selected branch, including both the files and the git history. It might help to remember that we use git checkout to check out the latest snapshot for both files and for branches. All right, let's switch to our new feature branch by calling git checkout new feature and then listing our branches once again. Before we were working on the master branch, but now that we've changed to our new branch, the star has moved to a new feature. Creating a branch and switching to it immediately is a pretty common task. So common that Git gives us a useful shortcut to create a new branch and to switch to it in a single command. We can use the git checkout -b new branch to do this. Take a look. See how the message says that we've switched to a new branch? Git created a new branch and switched to it in just one command. Super efficient. Now that we have our shiny new branch, let's create a new file in. We'll create a new Python 3 file that will include the usual shebang line, an empty main function, and a call to that function. This file is empty because it's only the beginning of our work. As it's in a separate branch, it's okay for it to not be finished yet. Let's save our file and commit it to the current branch. Now, We've added a commit in this branch, and it's looking better. Let's check the last 2 entries in the log. We see the last 2 commits in this branch. Notice how next to the latest commit ID, Git shows that this is where head is pointing to and that the branch is called even better feature. Next to the previous commit, Git shows that both the master and the new feature branches are pointing to that snapshot of the project. In this way, we can see that the even better feature branch is ahead of the master branch. With that, we've seen how we can create new branches and commit changes to them. We created a new branch different than the master branch and added a commit to it. Let's check out the current status of our repo by calling git status and ls-l. So we see that we're on a clean working tree in the even better feature branch and that a new free memory.py file is in our working tree. Let's now change back to the master branch using git checkout master and then list the latest 2 commits there. When we switch to a different branch using git checkout, under the hood, Git changes where head is pointing. Thanks to this checkout, head went from pointing to the latest commit in the even better feature branch to the most recent commit of the master branch. The commit from even better feature doesn't show up at all, and the latest snapshot is the second entry we've seen before. Remember that when we switch branches, Git will also change files in our working directory or working tree to whatever snapshot head is currently pointing at. Let's look at the current contents of our directory. Free memory.py isn't there. This demonstrates that when we switch branches in Git, the working directory and commit history will be changed to reflect the snapshot of our project in that branch. When we check out a new branch and commit on it, those changes will be added to the history of that branch. One thing to note after all this back and forth is that each branch is just a pointer to a specific commit in a series of snapshots. It's very easy to create new branches because there isn't any data that needs to be copied around. When we switch to another branch, we check out a different commit and Git updates both head and the contents of our working directory. Okay, we've now seen how to create and switch between branches. So what if we want to delete a branch that we don't need anymore? We can do that by using git branch-d. Let's first list the current branches in our repo and then get rid of the new feature branch by calling git branch-d new feature. Just like that, our branch was trimmed. We can check with another call to git branch that is not there anymore. If there are changes in the branch we want to delete that haven't been merged back into the master branch, Git will let us know with an error. Hopefully, Git also gives us the command to run if we were sure that we wanted to delete the branch, even if it has unmerged changes. But we won't do that just yet. We actually want to merge those changes back into the repo first. How do we do that? Merging is the term that Git uses for combining branch data and history together. We'll use the git merge command, which lets us take the independent snapshots and history of one Git branch and tangle them into another. Let's try this out with our example branch. First, we'll check that we're in the master branch, and then we'll call git merge even better feature to merge the even better feature branch into the master branch. Now we've brought the master branch up to speed, which we can see by looking at the Git log. As we're on the master branch head points at master, we can see the even better feature and master branches are now both pointing at the same commit. From time to time, we might find that both the branches we're trying to merge have edits to the same part of the same file. This will result in something called a merge conflict. Normally, Git can automatically merge files for us, but when we have a merge conflict, it will need a little help to figure out what to do. To see how this would look, let's edit the free_memory.py file in the master branch and replace the pass statement with a comment about what the main function should do. Cool. We made the change, so let's save it and commit it back to our master branch. Next, let's check out the even better feature branch and make a change in the same place. In this case, we will replace the call to pass with a call to print, saying that everything is okay. Now, we'll save this other change and commit it to this branch. We are primed for chaos with our file all set up for a merge conflict. Let's check out the master branch again and try to merge the even better feature back into it. Git tells us it tried to automatically merge the two versions of the free memory file, but it didn't know how to do it. We can use git status to get more information about what's going on. As usual, git status gives us a lot of additional information. It tells us that we have files that are currently unmerged, and that we need to fix the conflicts or abort the merge if we decide it was a mistake. It also tells us that we need to run git add on each unmerged file to mark that the conflicts have been resolved. Let's get to work. To fix the conflict, let's open up free_memory.py. Thankfully, Git has added some information to our files to tell us which parts of the code are conflicting. The unmerged content of the file at head. Remember, in this case, head points to master is the doc string stating what the main function should do. The unmerged content of the file in the even better feature branch is the call to the print function. It's up to us to decide which one to keep or if we should change the contents of the file altogether. In this case, we'll keep both statements and delete the merger markers. Now that we've fixed the conflict, we'll mark it as resolved by running git add on the file, and then call the git status to see how our merge is doing. See how Git now tells us that all conflicts have been resolved. Now we just need to call git commit to wrap up the merge. The comments that git commit shows us look different than other commits. That's because this is a merge and Git tells us so. It also tells us which file had conflicts which have now been resolved. The commit already has a description saying that it's merging the other branch. This description was automatically created when we called the git merge command, but we can add on to this description if we want. For example, we can say that we're keeping the lines from both branches and then just save and exit as usual. The merge conflict is resolved. To see what the commit history looks like now, we'll use a couple of handy options to the git log command. --graph for seeing the commits as a graph, and --one line to only see one line per commit. This format helps us better understand the history of our commits and how merges have occurred. We can see the new commit that was added and also the two separate commits that we merged. One coming from the master branch and the other coming from the even better feature branch. We can also see that master is pointing to the merge commit, but even better feature is still pointing to the previous one. In our example, resolving the conflict was straightforward and easy, but in the real world, this won't always be the case. Merge conflicts can sometimes be tricky, complicated, and spread across multiple files. If you want to throw the merge away and start over, you can use the git merge --abort command as an escape hatch. This will stop the merge and reset the files in your working tree back to the previous commit before the merge ever happened. So by now you know how to create, delete, and switch between branches in Git. You've also seen that each branch represents a pointer to a commit in a sequence of independent snapshots. You know how to merge these commits back into the main trunk by using the git merge command. That's all for now. Don't forget to smash that like button, subscribe, and ring the bell to stay updated. In the next video, we'll learn a load of new things related to GitHub and remote repositories. Thanks for watching, and see you soon.